Hello, everybody. Today we're going to be talking about vectors. V-E-C-T-O-R-S. See how that goes? But we're not going to be talking about what vectors are. What we're going to do more is talking about how to manipulate vectors, how to add vectors, how to find parts of vectors called components, stuff like that. But real quick, just in case you don't know. A vector is a physical quantity that both has an amount and a direction. So velocity is a vector. The magnitude is how fast something's going. So let's say a car is moving 12 meters per second. Right there, 12 meters per second, that's only a speed. But if you say a car is moving 12 meters per second east, now we have a magnitude, that was the 12 meters per second, and we have a direction, that's east. That's what a vector is. Scalars are objects or physical quantities that don't have direction. An example of a scalar, well, speed's a scalar because it's just how fast without direction. Distance is a scalar because it's just how far. Displacement is a vector because displacement is how far in a very specific direction. And mass. Mass is a scalar. There's no direction for mass. It would make no sense to say, Mr. O'Hagan, his mass is 100 kilograms southwest. I mean, that would be ridiculous. Okay? So anyway, let's start talking about vectors. And the first thing we're going to do is we're going to add some vectors graphically. And I'll show you how that works. So to add vectors graphically, we need to get graph paper. All right, so here's some graph paper. And let's say I have an object right here. And I'm gonna add up some forces, okay? So let's say I've got an object right here, and I've got two forces on it. I got a force that pulls to the right at, all right, I'm gonna cheat. I'm gonna do some numbers that I know how it's gonna work out. All right, pull to the right with a force of 8. So I'm going to go 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. So that's my force 1. And we're going to have another force on it. It's going to be pulling straight up. Well, not up. Just like in a plane. This would be like sideways one direction and 90 degrees in another direction. Anyway, but not up and down. I don't want to worry about gravity pulling the other way. Okay, so anyway, I got a force pulling up, and we're going to have this one pull up with 6. 1, 2, 3, 4, 5, 6. And this I'll call force 2. The question is, which way is the overall force, the net force? Because if we pull to the right and we pull up, I believe you're going to end up getting a force which is kind of that way, and a little bit more to the right than towards the top of the paper. So if you want to figure out how to do this graphically, here's what you do. Graphically, you kind of create a rectangle out of these. So I'm going to go down, and I'm going to go down. And you could use like a protractor and stuff like that if you didn't have a nice graph paper. The net force, the resulting force, if you take force 1 and you add it to force 2, we're going to do something called our force net. That's our addition of the forces. And that's going to go up to this point right here. Okay, if you recall, I said force 1 was 8 newtons. And I represented it with 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. I said force 2 was 6. Newtons were implied. And of course, that means I went towards the top of the sheet of paper. 1, 2, 3, 4, 5, 6. And boy, I hope these are nice. These little boxes are something convenient. Oh, the box is 1/4 inches. Okay, well, it's not so convenient. All right. Anyway, so now the question is, how big is the overall force? Well, let's find out how many 1/4 inches it is, because this is the way it works. So I'm going to rotate this around a little bit. So starting here, I'm going to, because that's in the way, I'm going to do it this direction. All right, so the number of 1/4 inches we've got All right, so let me get a handy dandy little counter here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 quarter inches. So this force net is equal to 10 blocks. And basically a block's a quarter inch. And so that means it's 10 newtons. And I just did that drawing. You can just do that drawing. You know, if you're not sure that these are quarter inches, I said this one was 8. It should measure to be 2 inches long, because that would be 8 quarter inches. Yeah, it does. Okay, 2 inches long. All right. So that's how you add up vectors graphically. Pretty interesting thing to be able to do, but we're not going to do it in this class that much. But it gives you kind of the ideas of what's happening. All right, some other things with vectors. Before we get to adding vectors without doing it graphically, let's talk about taking components. Components are like a part of a vector. So for example, here's the ground. I'll make the ground green. And we're going to do projectile motion. I'm going to kick a ball. All right, so I'll make it a red ball, beautiful red ball. Oh, look at that red ball. And hey, it's soccer season, so we'll kick a soccer ball. How do I want to kick it? Let's kick it this way. And let's say we kicked it with a speed of 15 meters per second. And let's say we kicked it at an angle of 20 degrees above the horizontal line. So it's going to go up into the air. Projectile motion, kind of like that. But if we're going to solve projectile motion, and we'll do that later in the class, you need to know how fast this ball is going in the horizontal direction, and you need to know how fast the ball is going in the vertical direction. So I'm going to take this component, I mean, not this component, I'm going to take this vector, and back here. Remember how we took these two vectors here, and we added them to get this diagonal one? Well, we're going to take the diagonal one, and we're going to undo it, and we're going to get this, which is velocity in the x, and we're going to get this one, which is velocity in the y. And these two things are called components. They're called components of the 15 meter per second velocity. And if this is going to be a velocity, it's not only 15 meters per second, it's 15 meters per second at 20 degrees above the horizontal line, or above the horizon. Okay, so here's how I get velocity x and velocity y. So velocity x is going to equal, oh, look at this. I'm seeing a right triangle. Look at that beautiful right triangle. And what do we know? We know the hypotenuse of that right triangle, and we're trying to find the adjacent side. There's got to be some trig thing that links up hypotenuse and adjacent side. I have no, oh, wait, I remember. I learned this a long time ago. SOHCAH, TOA. So, got to get that H in there. TOA. All right, so which one of these, and remember, this is sine equals the opposite side divided, oh, you can't see what I'm writing there. It's way too small. Divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. And TOA is tangent of the angle is the opposite side divided by the adjacent side. So here we go. Which one of those is going to help us solve this? We have a hypotenuse and we're looking for an adjacent side. Hypotenuse and adjacent side, that looks like it's going to be cosine. So real quick, I'm going to come back to that. Cosine of the angle, my angle's 20 degrees, is equal to the adjacent side, ADJ, divided by the hypotenuse. All right, what do I know? I know the hypotenuse, and I know the angle, so I got the cosine of the angle. I'm looking for the adjacent side. So the adjacent side ends up being the hypotenuse times cosine of the angle. All right, so let's put this into my physics variables. The adjacent side, that's velocity in the x, that's what I'm looking for, is equal to the hypotenuse, that's the 15, times the cosine of 20 degrees. And I'm sorry, everything's starting to run together. Okay? At this point, I can't do that in my head, but I can do that on a calculator. All right, so let's see. Does that help if that's not? No, it doesn't really matter much. One either way. Okay, first I'm going to check the mode. What are we in? Oh, we're in radians. I better get out of radians or this ain't going to work very well. Okay, so what did I say it was? 15 times cosine of 20. Hey, I like that in parentheses because you don't really have to, but I do. Let me get this mouse out of there. Equals 14.095, 14.10 if you round it. So this is 14.10 meter per second. And then what's the velocity in the y? All right, the velocity in the y, oh look, I still see a right triangle. Remember, what we've got here is a rectangle. So this side of the rectangle, the opposite side of the angle, is the exact same as what we're trying to find here, this velocity in the y. So if I can find this opposite side, I've got it. All right, so which one of our trig functions hooks up angle, hypotenuse, and opposite side? The sine is the opposite divided by hypotenuse. It's that one. All right, I'll quick do that little rundown over here. Sine of the angle is the opposite divided by the hypotenuse. Therefore, the opposite side, that's what we're looking for. We're looking for this because that's the same as velocity in the y. Equals opposite side hypotenuse times the sine of the angle. Okay. Now you can skip that if you just know it's going to be the hypotenuse times sine of the angle. I mean, I don't care. But that's where it comes from. So this is going to be the hypotenuse. Again, that's 15 times the sine of 20 degrees. All right, here we go. On 15 sine 20, boom, 5.13. All right, so this one is 5.13 meters per second. Okay, so that's how you find the components. That's how you find the x and y parts, okay, of a vector that's at an angle. All right, so far so good. Now, let's say that, oh, got to be careful, I'm going to lose some stuff over here. I don't want to lose. All right, so let's say that, now we get to the good stuff. Let's say we want to add vectors. Remember last time we added the vectors graphically. Oh, something we didn't do when we added them graphically. We found out how big it was. We never found out the angle. Oh, no. You need a protractor to find out the angle. Use the protractor, and it's, oh, my protractor's upside down. Use the protractor, and what do we get? We get, somewhere around 38, 39 degrees, something like that. I can't tell. All right, but anyway, you can measure the angle doing it this way. All right, we don't like to measure stuff in this class. Well, when doing these type of calculations, nobody likes to measure. We'd much rather just do the math for it. So let's do the same problem, but let's use trigonometry to solve it. So here we go. I'm going to say, I'll even use the red like I was doing before. Nope, I'll start with green. I'll even say force 1 is 8, force 2 is 6, and I'm looking for, I'm going to make a rectangle. I'm going to be looking for the net force, which is that one right there. This is what's called the vector addition of these two. All right, I'll label it even. Force net. Okay, here's how we do this. Again, it goes back to trig. Do you see a right triangle? I do. And do you understand, because we've made this with a rectangle, that this side of my right triangle is going to be equal to 6. That's still equal to 6. So now I have a triangle like this, where I know this side's 6, this side's 8, and I'm going to solve for the hypotenuse. So if I've got the two sides I'm solving for the hypotenuse, that's tangent. tangent of the angle equals the adjacent divided by the hypotenuse. Wow, I'm so good at writing. So then, if we're looking for the hypotenuse equals, oh, why do it this way? This is silly. I'm so sorry. Forget that. How about this? A squared plus B squared equals C squared. Right there. Isn't that Pythagorean guy's stuff? Let's use this. Force net, this is like the seaside, oh, it's a seaside resort. The C side of a right triangle. So if I want to just get the C side, square root everything, equals the square root of 8 squared plus 6 squared. All right, so what's this going to be? Square root of 64 plus 36 equals square root of 100 equals 10. Just like we said it was. 10 newtons. Okay? And I knew what the answer was going to be because it's a 3, 4, 5 triangle, but I just puffed it up on steroids. Okay? All right, but now, how do we get the angle? And this is really the neat part about doing it this way. The other way I just measured and it was like, like 38, something like that. 39, 38, 37, I don't know what it was. Here's how we do this one. Get the angle. I'm looking for an angle, and I've got an adjacent side and an opposite side. I'd rather not use my result for the force, for the net force, the one I did the calculation for, because if I screw this calculation, I don't want to use that screwed up number again to find the angle. So I'm going to use the opposite side and the adjacent side. That ends up being tangent function. Okay? Tangent of an angle equals the opposite divided by the adjacent. But I don't want tangent of the angle. I want the actual angle. So here's how you do that. Angle is the inverse tangent, or when I was a kid, it was called the arctangent, of the opposite divided by the hypotenuse. So in our case, the angle is the inverse tangent of the opposite side. Opposite side is this, and that's going to equal 6. 6 divided by the adjacent side, that's 8. And I just happen to know this off the top of my head, 36.9 degrees. I don't know why I remember that. Well, I do know, because it's 36.9. It's kind of a cool little thing here. All right, I could have used my calculator, but anyway, that's it. So we know this vector. We know force net, and here's how you'd have to say it, the whole thing, equals 10 newtons at, that's supposed to be an at symbol, 36.9 degrees. And of course, this assumes that, let me go to this color, that 0 degrees is this way, and the angles get bigger going counterclockwise, which is what we do in math, so that seems to make sense. Okay, so that's how I add up two vectors using trig. But these vectors just so happen to be at right angles. How darn convenient. They're not always going to be at right angles. Poof. So here's how you do this one, if they're not at right angles. All right, and I'm going to use my green because my green has the sharpest edge here of the lot. No, actually, I'll start with my blue, and then I'll move to the green when I need to. All right, so let's say vector 1, I don't know, it could be a force, it could be a velocity, whatever, is going to be, give me a number, kids. All right, 6 newtons, oh no, it can't be newtons, meters per second at, and then how's about we go 30 degrees. And let's say velocity 2 is going to be 15 meters per second at, all right, give me an angle there. Let's get crazy. Let's go across to the other way. Let's go 90 and 45, 135. 135 degrees. Oh, that's going to be nuts. Oh, no, I don't want to use that. There's a reason why I don't want to use that. I don't want to use that because the X and Y parts will be the same. Let's say 120. 120 degrees. Okay, I need to add these. I'm looking for velocity, and velocity is velocity 1, velocity total, plus velocity 2. All right, so you can't just go, hey, 6 and 15, 21, yay! No, these are vectors, even though I'm lazy and don't draw those. These are vectors, and you have to take direction into account. So here's what the picture looks like. I'm going to real quick do this. And my first vector is 6 at 30 degrees. So 30 degrees is about like there. So there's 6 at 30 degrees. All right. My second vector, and I'm going to draw it right yeah, I mean, okay, you can do, I'm going to draw it. How do I do this? Here's the deal. When you think about forces, you always think about them coming from the same spot. But when you think about, well, I'll draw it from the same spot. I'll explain what I'm thinking about here. My second vector is longer, and it's up this direction. So this is 15, and this one is 6. I wish I had done my 15 there. Okay. Some people draw it, and I'll show you. They'll draw it this way. They'll go 6, and then 15. Now, if you're clever, you know that's a right angle in there, but I don't care. We're not going to deal with that. I'm going to teach you as if there was not a right angle in there. Okay? Either way, it all works out the same. Let me show you what I'm going to do. I'm going to take this vector, and I'm going to find its components. I'm going to find the side-to-side part to it, and I'm going to find the up and down part to it. This would be velocity 1 in the y. This would be velocity 1 in the x. Okay, 1 in the y, 1 in the x, those are just subscripts. You know, it's velocity 1, because that's my velocity 1 vector, and then the y part and the x part. This one, we're going to find velocity 2 in the y and velocity 2 in the x. We're going to find those chunks. Now, once I have all those 4 chunks, then I can just add up the 2 up ones. I can do a little subtraction because it's a tug of war on these ones. And then I'm back to 2 vectors just at right angles, which we did here. Okay? But I first got to find these chunks. Now, you can do the exact same thing over here. If you draw them this way, it makes no difference. You just solve for that bit, and then this bit, and then this bit, and that bit, and you get right back to the same spot. All right, you just add the 2 ups, the right and the left. You just end up doing a subtraction. Whichever one's bigger, that's the direction you're going to be going. Okay, so it doesn't matter if you draw them, if you draw one coming right after the other, or if you draw them all out of the same spot. Doesn't matter. And once you get the hang of this, you won't even draw them. You just do it. Okay, so here we go. I'm going to solve for all these chunks, and I'm going to make a little table of values. All right, so here's how I like to do this. Velocity 1 in the x, velocity 1 in the y. Velocity 2 in the x, velocity 2 in the y. Equals, 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 equals. Okay, I am always going to use the angles right here. I like those angles. And when I do that, because I do that, and I'll say the angle over here. So I'm always going to close off my triangles on the left-right side. If I do that, the cosine is always the x component, and the sine is always the y component. All right, now it gets kind of weird for a second here. This angle is 30 degrees. That's easy. Oh, I got to write a lot bigger. This angle is 30 degrees, this one right here, because that's what we said. Over to the right, this is 0 degrees, of course. Going counterclockwise, they get bigger. This angle here is not the 120. All right, 120 is from 0 all the way to this. So you got to use your brain at this point. From the 0 all the way to the other side, that's 180. I don't want the whole 180. I want 120 less. So 120 plus this must equal 180. I believe that makes this one 60 degrees. So no matter how you do it, you got to find a right triangle, and you got to get an angle in that right triangle. Okay? So here we go. Now I've got things kind of set up. All right. If I'm going to try and solve for this one, velocity 1 in the x. All right. I've got adjacent and no, I've got hypotenuse, angle. I'm looking for adjacent. That's going to be cosine. And cosine, the way you rearrange it, is going to be the hypotenuse, 6, times the cosine of the angle, which is 30 degrees. Okay. If I know this one, the adjacent side is 6 cosine, well, the opposite side is use the sine function. It's 6 sine 30 degrees. Okay? So now I know, once I do the math, these two parts. I know this part and I know this part. All right, and remember, because this up and down part's the same as this right side of my rectangle, even though I didn't finish the rectangle, but okay, there's a rectangle there. All right, now, velocity 2 in the x. That's this chunk here. All right, it's going to be cosine again. So now it's 15 times cosine of 60 degrees equals, and then this up and down part, which is the same as this side of my right triangle, is going to be 15 times sine of 60 degrees. All right, before you get out your calculator, and we'll get that out in a second, you got to take care of some directions. Because we're going to get just numbers out of here. Because once you get into the trig, it's just numbers, all right? But we got to take care of up, down, left, right on our own. So in general, not in general, everybody says towards the top of the sheet of paper is positive, and towards the right of the sheet of paper, that's positive. So that's the convention we're going to use. So here we go. This points to the right. That's going to be a positive number. That's going to be a positive number. This one points up. That's going to be a positive number. This one points to the left. Ooh, that one's got to be negative. This one points up. That's got to be positive. So now once we do our calculations, we'll get the correct numbers in here. All right, so on 6 cosine 30, I'm not good with this, is going to be 5.20. 5.20. And remember, I'm just rounding. There's a 6 after the 9, so the 9 becomes a 10. That makes it a 2. All right. 6 sine 30, I can do this one on my own. 6 sine 30 because sine 30 is a half, so this ends up being 3. 15 cosine 60, well, I can do cosine 60 because that's a half as well, so that's going to be 7.5. And then 15 sine 60, I can't do that one. So 15 sine 60 ends up being equal to 12.99. All right, so this is 12.99. And I've done all that work just so I can figure out the right and left part of this one and the up and down part of this one, and the left-right part of this one and the up and down part of this one. And now I can add those up. So this velocity in the x, so just the x part, it's these two put together, added, the x. I've got plus 5.2, that's from up here. I'm just going to add the x parts, minus this one, 7.5. Oh, what is that going to be? Minus 2.3. I'm not going to trust myself. I hate when I go across that 0 point. Clear. 5.2 minus 7.5. Yep, minus 2.3. Okay, I just get nervous. Minus 2.3. All right, velocity in the y. All right, the total up and down part. All right, total up and down part is going to be 3 plus 12.99. That's, I don't know what I did there. 15.99. All right, now we've done all that work. We've got two parts, and now we're back to this picture. We're back to a picture which goes minus 2.3. Actually, I don't care about the minus at this point because that just tells me which way to draw this picture. Up here, 15.99. And these two things we're going to add together as if they were forces or whatever. All right. give you a rectangle. We're looking now for, ooh, I'll make it red. This one right here. Okay. And so then the velocity, all right, this side's 2.3 of a right triangle. This side's 15.99. I believe Pythagorean theorem. Velocity is going to be the square root of 2.3 squared plus 15.99 squared. And it's going to be around 16. So second square root 2.3 squared plus 15.99 squared, enter, equals 16.15. 16.15. There's supposed to be a decimal point there. That is way better than we could have gotten with a ruler. Okay, now for the angle. All right, I'm going to do the angle in green, and I'm going to come back to it. Here's my right triangle. That's the angle I can solve for easily, but that is not the angle I want. Over here is the 0 degrees. I need this angle. So we're going to solve for the one we can solve for. Then you got to do a little work to get the one you actually want. So should I call this something different? Should I call this, I don't know what to call it. Whatever. Okay. I'll call that beta. All right. Beta equals, so I'm looking for the angle. That's going to be a tangent thing, right? Inverse tangent of the opposite. What's the opposite side? Opposite side is the one far away. That's 15.99. 15.99 divided by the adjacent side. That's 2.3. Now, sines and cosines and stuff, I mean, I'm just looking at a right triangle. So this negative means nothing to me. All right. So this is going to be bigger than 45, that's for sure. So on inverse tangent, 15.99 divided by 2.3, in parentheses on that one, 81.81. 81.81. All right, so that's what I got. That's this chunk here. But I need this chunk all the way over here. So I know from the 0 to this is 180, but we're going to back that up, 81.81. So the actual angle, oh, go red, because I was doing red with the other ones. The actual angle I care for is 180 minus 81.81. I cannot do this in my head. All right. 180 minus 81.81 equals, all right, 98.19. 98.199 degrees. Okay, that's how you add up vectors that are not at right angles. You got to find the xy parts. Once you find the xy parts, find the total in the x, total in the y. That's down here. And then you're back to adding up vectors that are at right angles. Okay, these are much better answers than you could have gotten with a ruler and a protractor. Okay, but the ideas are still the same. We're just using trig because trig is our friend. Not as good of a friend as algebra, but trig is a pretty darn good friend. So let me see what things we're supposed to talk about today. All right, vectors and scalars, talked about that. Adding vectors graphically, talked about that. Components of vectors, yeah, we talked about that. When we did this, we were taking components of vectors and adding vectors by components. Hot diggity dog, we've done it all. All right, if you notice, I got the sound going a little bit better on this video, so I'm quite happy about that. So, I got nothing more. All right, adios, everybody.